There is 16 and question paper 1-3. TK went to 16. So I'm gonna start with organic questions first, TK. We'll start ही कर लेते हैं. We're going to try and complete the whole paper, TK, the entire paper. W16. Question paper 1-3. TK, the first question that's about as remember W16 QP13. You can open this on your device as well. Just 1 second. So now starting with the first question, which is starting with the first question, Boltzmann distribution. This is a Boltzmann distribution. It's the distribution of molecular energies. Which dotted curve below shows the distribution at for the same reaction at a higher temperature. Okay, so he wants the distribution at a higher temperature, and on these diagrams, H represents the activation energy at the higher temperature. So the first thing is that the number of particles, the height is the number of particles. So at the higher temperature, the number of particles would increase, and at the lower energy, the number of particles will decrease. So the curve is going to shift to the right, which would make it option C. C hoga na? It's going to be, it's either C or it's B. It's either one of the two. Higher temperature, the curve will shift to the right. That's what's going to happen.
Sir, B में क्या issue है?
Achha, why not B? Okay, the reason it can't be B is that that he said that H represents the activation energy. The activation energy does not change. Jo pehle thi na, it's going to remain exactly the same. The activation energy never changes. Why does it not change? Because it only changes with a catalyst. Otherwise, it's not going to change. Is that clear?
Yes, sir.
So that's why it's C. Next one. In the ideal gas equation, PV is equal to nRT, what are the units of N and T? So units for N and T. Just 1 second. Okay, N is moles and T is going to be in Kelvins, right? That's the ideal gas equation. The next part is the reaction between either clear and a PVG or nRT. The pressure is going to be always in pascals. The volume will always be in meter cube, and the R is a constant. That's a gas constant. T is in Kelvins, and N is number of moles. The reaction between dichromate 6 and Fe2 plus ions results in the dichromate ions being reduced to Cr3 plus. What is the correct equation for this? So which one? And he's saying the reaction between acidified dichromate 6. I'll tell you, just for the sake of detail, TK, what I'm going to do is, let's say these equations are not given, although all of these equations are exactly the same. It's Cr2O7, Fe2 plus, 14H plus 1, Cr3 plus, everything is the same. Now remember, whenever you have a redox reaction, so what happens is that someone gains electrons, someone loses electrons. So the electrons gain and lost, they've got to be equal in a redox reaction. Whoever is gaining electrons, and whoever is losing electrons, they should be gaining and losing the same number of electrons. So if I were to make an equation from scratch, acidified means that there is H plus 1, so there's Cr2O7, 2 minus. Also, it's acidified, so that means there's acid H plus 1, and then there is Fe2 plus ions. And on the product side, I've got what? I've got dichromate 6 ions are reduced to Cr3 plus ions. And in all these equations, it's forming Fe3 plus and water. Now, whenever you balance the redox equation, the number of electrons gained and lost, they have to be equal. So इस केस में how can they be equal? Okay, they can be equal if Fe2 plus is the one that's getting oxidized. So it's going from Fe2 plus to 3 plus, so that means it lost exactly 1 electron. And ye koi batayega ki what is the oxidation state of Cr over here? In Cr2O7 2 minus, what is the oxidation state of Cr? वो कैसे निकालता था Cr की oxidation state? Cr2O7 2 minus Cr, you don't know what it is, so it's X, and there are 2 Cr, so the charge is 2X. Oxygen is -2, and there are 7 of them, and the total charge must be equal to -2. Individual charges, they add up. Oxygen is -2, chromium is X, you don't know what it is. So if you solve for this, it's going to come out to be क्या आएगा?
Six.
ठीक है, so you're going to get +6. So this is +6, Cr is +6, and Cr over here is +3. So it goes from +6 to +3. So that means it gained 3 electrons, right? So it gained 3 electrons. So electrons gain and loss, they have to be equal. Now there are 2 Crs on the left side, so there would be 2 Crs on the right side as well. That would mean, since each Cr is gaining 3 electrons, 2 Crs will be gaining a total of 6 electrons. TK, we said that Cr is +6, right? And over here we said that Cr is +3. So if it goes from +6 to +3, and there are 2 of them, so that means they're gaining 3 electrons, but there are 2 of them, so that means they're gaining 6 electrons. Now Fe must be losing 6 electrons, but right now it's losing just 1 electron. So I'll multiply that by 6. And if I multiply it by 6, now the number of electrons gained and lost are, they are equal. Okay, now the electrons lost and the electrons that are gained are exactly the same. Okay, you clear? Is this clear?
Yes, sir.
And then you can balance the rest of the stuff, which is H and O is left. So there are 7 oxygens. So there should be 7 H2Os. And that would leave you with how many hydrogens? That's 14 hydrogens. So there should be 14. So which is the correct equation? It's going to be Cr2O7 6 Fe2 plus and 14 H plus 1. I think
The
it's
last one.
I think it's the last one. Is this clear that all redox equations, you have to make the number of electrons gained and lost equal? Although this was a much simpler question, you didn't have to do that. I mean, you would have gotten the answer anyways if you wouldn't have actually, because all the other the other equations are also balanced. Like there's 7 oxygens. I mean, this equation atomizes balanced, but it's not balanced electron wise. It has to be, an equation has to be balanced electron wise as well. Lost and gain, they have to be equal. So in this case, you had to actually do this. You had to do all the working. So next one. Sodium azide is an explosive used to inflate airbags when they crash. It consists of positive sodium ions and negative azide ions. So it's NaN3, right? Now we know that Na is +1. So this N3 is going to be -1. So he's asking for the number of electrons in Na +1 and also in N3 -1. So Na is 11 in the periodic table. So कितने होंगे electrons? That's 10, right?
10.
One N has 7 electrons. So how many electrons do you have over here?
24. Oh, no.
The one N has 7 electrons. So how many N's do you have? You have 3 of them, right?
21 plus 1.
And 21, and it's got a -1 charge. So that means there's 1 extra electron. So it's going to be 22. So the answer will be B. ठीक है, clear?
Yes, sir.
As a next one is you've got an isotope. It's medically useful because it undergoes a natural radioactive process to give an isotope of a different element. So he's saying that there's an isotope and undergoes a radioactive process and gives you another isotope, which is this one. The transformation occurs when an electron enters the nucleus and changes the proton into a neutron. So as a pellet, you have to find out what is the composition of Ge. You need a periodic table for that because we need to find what X is. As a Ge is over here, it's the atomic number is 32. So that is the atomic number of Ge, that's 30. So that's 32. So you've got 32 protons and you've got 32 electrons. And you have how many neutrons? That's what's 68 minus 32? That's
36.
Okay, so you got 36 neutrons. Now, what is he saying? That an electron enters the nucleus and changes a proton into a neutron. So there's an electron that goes and changes one of the protons into a neutron. So now you have one proton is less because one of the proton has changed into a neutron. So the number of neutrons are going to be more. TK, is this clear?
Yes, sir.
Yes, sir.
Another lesser electron?
Yeah,
Like an electron?
but did he, so you can say that there's one electron missing now. But did that electron come from the outside or was it its own electron? We don't know about that. But you can say that, I mean, there's probably one electron lesser.
Okay.
And actually that is going to be the case because if it's a neutral atom, okay, so one electron is missing. So now you've got 31 electrons. That makes sense. So the new atom, will it have a nuclear number of 68? What is proton plus neutrons? That is 68. 31 plus 37, right? What is the proton number? That's 31. And how many neutrons do you have? So I think C is correct, right? Is that clear?
Yes, sir.
Let's play the next one. There's this molecule and you just have to write the bond angles. What is the bond angle of N over here?
So
Does it-
120.
No, it's not.
Yeah,
It's not
117, sir. 117.
117 भी नहीं है.
120.
So लोन पेड नहीं होंगे उस वजह से कम नहीं होगी.
एक second. Just 1 minute. अच्छा hello एक second. अच्छा क्या था 120? It's not 120 N.
So
Whenever N
107.5.
107 because when N makes it's going to be pyramidal because it's got a lone pair. ठीक है, so it's derived from a tetrahedral shape and because of the extra lone pair repulsion, it's going to be 107. अच्छा, what is C? Carbon making 4 bonds.
So 109.5.
Okay, that's 109.5. Up here, you've got, Acha, what is this CZ?
120.
Okay, that's 120. So आपके जो angles हैं, that's X, Y, Z, right? The smallest is X and the largest is Z. That's the next one. The approximate percentage composition of the atmosphere in 4 different planets. Which mixture of gases has the greatest density? So greatest density means all gases have the same volume. Density is mass over volume. So since all gases, they occupy the same volume, so it's basically the mass that we're looking for. So but without calculation, by just looking at it, which one has the greatest mass?
Hydrogen?
Which one?
Uranus.
Okay, so D is the one. Because these are the heavier gases, right? This is 16, this is 1. So the heavier your gases, I mean, for example, this planet, the last one has 15.2% and 2.3% of this. The other ones have more hydrogen in them and lesser amount of methane and helium. So it's probably going to be the last one, D.
Sir, B होगा फिर. B19 और उसमें 1 है.
Oh, it's a B के साथ ना, you could have a.
नहीं, उस पर CH for 1 है लेकिन सर.
Lekin phir bhi there's a doubt now because it could be B, it could be D. So how do you calculate the average? The average is, remember the formula for calculating averages, TK, that's you just multiply the value by its percentage abundance, right? And then you divide by 100. So if I do it for B, it's going to be 80 multiplied by what's the mass of hydrogen, that's 2, plus helium is 4, so that's 19%, multiplied by 4, plus there's methane, that's 16 times 1%, and all of that is going to be divided by 100. Okay, that's for B, and for D it's going to be what? I'll still go with D, TK, if I just want to 82.5 multiplied by 2, and then I have 15.2 multiplied by 4. And then the last one, that's 2.3 multiplied by 16. So what do you get?
Sir, ऊपर वाली की 2.52 है.
TK, the last one.
So 2.626.
I think it's
2.66?
2.626.
TK, anyway, so that's going to give you D, right? So that will give you D. So our guess was kind of right, that you had a higher percentage of heavy gases in this one. Okay. As the next one, an important next one is, can important reaction in the manufacture of nitric acid is the catalytic oxidation of ammonia. For every mole of O2 reacts in this way, 181.28 kilojoules of energy are released. A factory makes 2.5 into 10 moles of NO every day. How much kilojoules of energy is released? Now he's saying that 1 mole of O2 that reacts, this much energy is released. So for 1 mole of O2, the amount of energy that's being released is 181.8 kilojoules. And now he says that your factory produces 2.5 times 10 power 5 moles of NO. So if it produces 2.5 times 10 power 5 moles of NO, how much O2 is actually reacting? Well, the use ratio is 4:5. Divide this by 4, multiply by 5.
So 312500.
E125.
312.5 into 10 raised to power 3.
E होगा 2500, right?
Hmm.
So that much. So 1 mole of O2 produces this much. So your moles is 3125. 0 moles of O2. So according to the ratio, how much energy would be produced?
There's 5.68 10 to the power 7.
5 point into 10 plus 7, right? So that's going to be C. Okay, is this clear?
Yes, sir.
So the next one is, okay, sodium chromate 6 is manufactured by heating chromite, FeCr2O4 with sodium carbonate and oxidizing atmospheric chromite contains this much. So you think what happens in this reaction? So there's this reaction happening. What happens in this reaction? So chromium and iron are the only elements that are oxidized. So chromium and iron. So can you tell the oxidation state of is already told you that it's Cr2 of Cr2. I mean, this is the formula Fe Cr2O4, and he's already told you that Cr2O4 2 minus is the charge. So what's the charge on Fe over here in this case?
+2.
Okay, I mean, this thing over here, he's already told you that it's -2, so Fe must be +2. So Fe is +2, the other part is -2, and he's already told you that chromium is actually, what is the charge on chromium? It's +6. यहाँ पे given है sodium chromate 6, it's CrO4. What is the charge on Cr over here? That's unknown, so that's 2x. This is -2 times 4, and the total charge is equal to -2. So what would x be? X would come out to be, I think, +6. Is it coming out to be +6? Okay, -8. -8 goes to the other side, so that's +8.
3 hours, sir.
The +3, right? So Cr over
Yes.
here, that's a Cr over here is +3. N is probably just +1. What is the charge on Fe over here?
+3.
Okay, that's +3. What is the charge on Cr over here? That's +6. You already told you that sodium chromate 6. So that is +6. So what's the answer? The first one is not true because chromium, nothing is happening. Chromium is getting oxidized, right?
So इसका B है.
As a first में क्या issue? First में iron are the only elements. Iron is getting. What's wrong with the first one?
तो कार्बन को हमने काउंट ही नहीं किया. कार्बन वो ऐड हो रहा है ना.
The first में कार्बन को कर लेते हैं ना. It's carbonate, ठीक है. Carbonate is CO3 -2, right? So what is the charge on carbon? Carbon is X. Oxygen is -2 times 3. And the total charge is equal to. So क्या होगा? X will come out to be equal to +4, right? Or यहाँ पे if I do it for carbon dioxide, carbon is X, oxygen is -2 times 2. And the total charge is equal to 0. X comes out to be equal to.
+4.
अच्छा A ही है.
So A ठीक है, because nothing is happening to carbon, nothing is happening to sodium as well. Sodium is +1, sodium is +1 over here as well. Or ठीक है, so nothing is happening to sodium over here. Now the next part is the table shows the partial pressures. Partial pressures are given. You just have to find the value of Kp. What's the expression for Kp over here? Pressures due to products That's pressure of NH3, and that's going to be squared. And it's going to be divided by the pressure due to H2, which is going to be cubed, and the pressure due to N2. So you just have to plug in the values. The partial pressures are already given. So what do you get for this?
सर NH3 का कैसे फाइंड करेंगे?
Given in ammonia, that's full. Everything is given 4,000.
Oh, okay.
4,000 squared divided by what is hydrogen? That's 8,000.
Acids. Party.
4.46 into 10 raised to power minus 9.
ठीक है 4.46
यही है.
ठीक है. So now next one is the next one is an autocatalytic reaction is one in which the product catalyzes the reaction. So the product is the catalyst. Which one would be obtained if the rate of an autocatalytic reaction is plotted against time? Remember, the product is the catalyst.
Sir, is it B?
Now, what is the rate of the reaction at the end of a reaction? But it's not B.
B.
क्या होगा?
B.
The B is not right. As a reaction initially, will it be slow or fast?
So slow.
ठीक है, product is the catalyst, so that means initially you don't have a product, right? So initially the reaction is, the rate is going to be slow, and then the product is going to be formed, and the reaction will speed up. What will happen after that?
It will slow down again, C,
So C, okay, it will slow down again because the
because
reaction
the
will,
catalyst would be used up.
no, not the catalyst. Catalyst will be formed, lekin the reactants will be used up. You
Oh,
won't have
okay.
any, you will not have any reactants to react. So it's going to be C. अच्छा फिर this question, there's a 1.15 gram of metallic element needs 300 cm cube of oxygen for complete reaction at 1 atmosphere pressure. So this is room temperature, so you can use the 24 dm cube. Like 1 mole of gas occupies 24 dm cube. And it forms an oxide which contains O minus 2 ions. So starting with calcium, he says calcium reacts with oxygen, and there's 1.15 grams of metallic element calcium. I'm just taking A as an option. It reacts with oxygen, that's 300 cm cube of oxygen. And it produces an oxide that contains O minus 2 ions. So it's going to be calcium oxide. And you can balance this, it's going to be 2:1. Does this data match the equation? How many moles of calcium do we have? Mass over AR of calcium, which is 40.1, mass over AR. So how many moles do we get?
0.0286.
0.
0286.
So what are the moles of oxygen? That's 0.3 dm cube divided by 24 dm cube. 108. That's needs not 108.
0.0125.
It's 0.0125. Is the ratio matching the equation? It's 2:1. So it's not really 2:1. I mean, the mole ratio is not 2:1, which means that this is not the equation that they're looking for. This is not the reaction that they were talking about. Otherwise, the mole ratio would have come out to be 2:1. So the data is not actually matching the equation over here. Is this clear?
Yes, sir.
Yes.
So the first one is wrong. Now, the problem with this question is you would have to, I mean, you can only do trial and error in this. You have to work it out for each one of them. So the next one I'm going to do is, I'm going to do the second one. Let's say it's magnesium, right?
सर
So-
अगर हम सर ऑक्सीजन के थ्रू हम क्या कहते हैं मोल्स रिक्वायर्ड फाइंड कर ले तो हमें मैच दिया हुआ है फिर हम डायरेक्ट एमआर फाइंड करके वो चूज नहीं कर सकते हिट एंड ट्रायल के बजाय
नहीं, मोल्स तो हमें पता है ना ऑक्सीजन के मसला वो in every equation the ratio is going to come out to be different. For potassium it's going to be a different ratio. So you would have to make the equation separately for potassium. The only thing that's going to remain constant is this thing. क्या ठीक है, oxygen will remain constant, right? Every time the equation will change, its ratio will change. So हर दफा you basically have to pretty much do it all over again. Is that clear?
यस सर
So if I do magnesium, in the case of magnesium, the ratio remains the same. So what you can do is you can find the moles of magnesium using this, double it, and then multiply by MR. If you don't get 1.15, then it's obviously not the correct one. So let's do it that way. Okay, if oxygen is 0.0125 moles, double it, so what do you get?
Zero 0.025.
So you're going to get 0.025 moles. And you multiply by MR, that's 0.025 multiplied by the AR of magnesium, that's 24.3. So I don't think that's going to come. Is it coming out to be 1.15?
No, sir. 0.6075.
Okay, so that means this is again not the right option. So we can now go for the other one, which is what's the next one? Potassium. Now potassium is going to form K2O. This would be 2, this would be 4. So double, now multiply this by 4, 1:4. So how many moles do you get? 0.0125.
0.05.
फिर उसको multiply with 39.1 as well.
One 1.9552.
Again, it's not this one. And it's going to be sodium. That's the only one that's left. So you can either waste time doing that. I mean, let's do that. So the last one is sodium, and that will be correct. So 4 sodiums, 2 sodium oxides. Okay, it's going to be balanced. So multiply the moles by 4, 0.0125, multiply by 4, and then multiply by it by the AR of sodium, which is 23.
Sir, 1.15.
Okay, so the D is correct. Okay. So in this case, the only option was that you had to just like go for each one of them and find out for which one the data is correct. As a next one, this is inorganic chemistry now. So the melting points of 8 elements with consecutive atomic numbers. Which element could be, so melting points, this is period 3. So which one is sodium? And this shows the melting points of 8 elements with consecutive. Which element is this one, by the way? The one that has the highest melting point in a particular period.
The silicon.
Silicon.
Okay, that is
Silicon.
silicon. And then this will be aluminium, this will be magnesium, and this will be sodium. Before sodium, you've got neon, which is a gas. So it's going to be C. उसके बाद क्या होता है? It's after silicon, you've got phosphorus, P4. You've got sulfur, which is S8, and then you've got chlorine, which is again a gas. And you've got what's after chlorine? That's argon. Okay, so it's going to be so this is period C melting points. Chlorine, the properties of chlorine, bromine, and their compounds are compared. What property is smaller for chlorine than for bromine? Chlorine is the smaller atom, bromine is the bigger atom down the group. So bond strength of the bond, smaller for chlorine. We need a property that is smaller for chlorine. So bond strength, will chlorine have a stronger bond or weaker bond?
Stronger.
Stronger. Smaller atoms always make stronger bonds. So the first one is wrong. It's not going to be smaller. The first ionization energy, would it be difficult to remove electrons from chlorine or easy?
Difficult.
Okay, smaller atoms, the electrons are less shielded and they're more strongly attracted to the nucleus. Plus they're closer to the nucleus. So this is going to be much higher. So ये smaller नहीं होगी. Solubility of the silver halide. So AgCl, is that soluble or AgBr soluble? Which of the precipitates are soluble when you test them with, and he's talking about the halides.
I think Cl.
Okay, the white precipitate of AgCl is soluble in dilute ammonia. AgBr is partially soluble or dissolves in concentrated ammonia. And AgI is not soluble at all. That's a yellow precipitate. So again, it's more soluble. So it's not smaller. Strength of van der Waals forces. What happens to van der Waals forces down the group?
Increases because bigger molecules have higher van der Waals forces.
Okay, bigger molecules have more van der Waals forces, so that is going to be smaller. So the answer will be D. Okay, van der Waals forces, they depend on the size of the molecule. Okay, is this clear?
Yes.
Achha, next one is, okay, at 550 nitrogen dioxide, okay, there's reacts with unburnt hydrocarbon fragments such as CH3 in the catalytic converter of a motor vehicle. And then he says this is the reaction. So nitrogen oxides, the unburnt hydrocarbons, they react. The following table lists types of energy changes for the reaction and possible reasons for them, which row gives the correct energy change, which row gives the energy change for this reaction and the reason for it. So what do you think is the energy changes? Now this is, all of them are gases. You can calculate them. You've got a data booklet with you as well. But by just looking at it, do you think it's exothermic or endothermic?
Sir, exothermic.
And why is it exothermic?
Sir, carbon dioxide, hydrogen, and combustion area.
It's looking at the same time, there's reduction happening as well. So exothermic, carbon have large negative delta HF values. These two are definitely और दूसरा दिया double bonds are broken in NO2. C makes a lot more sense. Why? Because CO2 and H2O have large negative delta HF values. That's combustion. Enthalpy of formation of carbon dioxide is actually the combustion of carbon. Enthalpy of formation of water is basically the combustion of hydrogen gas. And both of these values are going to be negative. Enthalpy of formation kya hota hai? It's carbon elements forming carbon dioxide, right? And formation of H2O is water getting formed from hydrogen and oxygen, right? So it's the combustion of hydrogen and it's the combustion of carbon. Combustion is negative. So both of these values are definitely negative. And they're very strongly negative because it's combustion, and opposite, you've got 6 water molecules and you've got 4 carbon dioxide. So there's a lot of combustion that's happening. And if enthalpies of formation of N2 would be 0, elements formation that's 0, enthalpy of formation of NO2 will, and there's enthalpy of formation of CH3 as well. Now the reaction enthalpy change is basically the enthalpy of formation of the products minus the enthalpies of formation of the reactants. So the question is that if the product enthalpy of formation is highly exothermic, if it's highly exothermic, then your overall enthalpy change will come out to be exothermic. If the product side has a lot of negative enthalpies, so overall enthalpy of reaction will eventually come out to be negative as well. So that makes a lot more sense. But did you understand this?
Yes, sir.
Okay, we had a formula that was that if you are given the enthalpies of formation of the reactants and you're given the enthalpies of formation of the products, then the enthalpy change of the reaction is basically the formation of products minus the formation of reactants. It's the difference between the two. And since these two are combustion and this is 0, so combustion is very exothermic, so all of them will come out to be, the product side will be very, very exothermic. And if that is negative, that means the overall enthalpy of reaction would also come out to be negative as well. TK, is this clear?
Yes, sir.
Yes.
So now magnesium nitrate will decompose white solid in a mixture of gases. And so what happens when magnesium nitrate composes? What's the product?
Nitrogen dioxide and oxygen and magnesium oxide.
And oxygen, half O2 and. So the question is, there's 7.4 grams of this. 7.4 grams, how many moles is this? 7.4 divided by the MR of magnesium nitrate, that's 24.3. Plus NO3 is 16 into 348 plus 14, that's 62 into 2, that's 124. That's NO3 twice. So tell me, how many moles do we have?
Sir, 0.05.
So you've got 0.05.
05.
So you got 0.05 moles. What is he asking? He's asking what is the mass of X produced? So he's basically asking for the gas, which is the oxide of nitrogen, that's X. So the moles of NO2 would be double that. So it's going to be what? 0.10 moles, right?
Yes.
And mass, so NO2 is what? N is 14 plus 16 into 3, that's 46. 16 times 2, that's 32. Plus 14, that's 46. That's the MR. So D is the answer.
4.6.
Okay, so D is the answer. So now next one. कोशिश करनी मैं पूरा ही पेपर करें, ठीक है? Now next one is compound T is a white crystalline solid. When sample of T was mixed with aqueous NaOH and heated, a pungent smelling gas. What is a pungent smelling gas?
Ammonia.
Ammonia.
ठीक है, ammonia. So पहले बता दो, what is the equation? What compound forms ammonia gas when it's heated with a base?
Is it ammonium salts?
Ammonium salts, right? So ammonium salts, any ammonium salt, when you heat it with a base like sodium hydroxide, OH ions, what happens is, I mean, the Na is a spectator ion, so I'll just the ammonium ions, they lose an H+1, they turn into ammonia. and the OH they gain in H+1 and they turn into water. And the whatever's left, that's your salt. So that's one thing. So the compound has ammonium ions. T has ammonium ions. So it's either A or B. The next part, does it have carbonate or does it have sulfate? So further testing, barium chloride was added at dense white. What's the test? What ion is tested with barium chloride? Is that a test for
Sulfate.
carbonate?
Sulfate.
Sulfates.
TK was sulfate ka test. So there's definitely sulfate ions in this. So it's going to be B. That's the answer. TK? Or ये reaction it comes very often in almost all papers. That's ammonium salts. Whenever they react with bases, they end up as ammonia gas and water molecules are produced. As a next part, which row gives the correct comparison between the solubility of calcium and barium hydroxide and the thermal stabilities of what happens to the solubility of hydroxides down the group?
Increases.
Increases. Barium hydroxide is very soluble. But calcium hydroxide is not that soluble. So calcium hydroxide is going to be lower and this one would be higher. Who's more stable? What happens to the stability down the group?
Increases.
वो भी increase करती है. So calcium carbonate would be lower. Thermal stability, barium carbonate will be having a higher, it's more stable. So the answer is D in this case. As the next part, remember the trends in group 2 that you've got the trends in hydroxides, the solubility increases down the group. You have a trend in the stability of carbonate and nitrates, it also increases down the group. And the solubility of sulfates, it actually decreases down the group. As the next part, X, Y, and Z represent different halogens. The table shows the results of 9 experiments in which aqueous solutions of X2, Y2, Z2 were separately added to a separate solution, aqueous solutions of X-1, Y-1, and C-1. So halogens and halides. So which row of the following shows that contains the list of the ions as reducing agents, decreasing strength as reducing agents? That's the first thing. If I have Cl-1 and Br-1 and I-1, which one is a better reducing agent?
I minus.
Okay, down the group, they become stronger. Reducing agents. Even notes go, let's okay. What happens down the group is so what happens? You know this. As a group 17, you can remember they become stronger reducing agents down the group. Why do they become stronger reducing agents? Because bigger ions, they lose electrons easily. They're more shielded. So they lose electrons very, very easily and they become better reducing agents down the group. So in this case, what happens is that if I react Cl-1 with, let's say, the Cl-1 is a pretty bad reducing agent. If I react I-1 with chlorine, the I-1 will lose electrons. It loses electrons very easily. And it's a powerful reducing agent. It will reduce chlorine to Cl-1. It will give its electrons to chlorine and iodine will be formed. Isko double kar lo. Okay, so a more powerful reducing agent will reduce the element. And that's what's going to happen. Okay, is that clear? It will lose electrons, the other one will gain electrons. Now in the first one, who do you think is the most powerful out of X-1, Y-1 and Z minus 1. Which one is the weakest reducing agent? That's going to be Y minus 1. Because it's not reacting with anyone. It's not losing electrons to anyone. Is that clear?
Yes, sir.
Yes, sir.
So that's the weakest. So that's Y minus 1. That's so it's either B or D. And which one is the strongest reducing agents? Is that X minus 1 or Z minus 1?
X.
X.
Okay, so X minus 1 is able to lose electrons to with Y2 as well and with Z2 as well. So that means it's undergoing more oxidation reactions. So which is why X minus 1 is the powerful reducing agent. So that's the strongest. Okay, is this part clear?
Yes, sir.
Yes, sir.
So next is so organics. You've got this structure which is C6H6. That's benzene, and that's a Kekuले structure in which a hydrogen atom is attached to each carbon atom. So it's 3 alternating double bonds. In this structure, all of the bonds remain in the place shown. Assuming this is the structure of benzene, how many isomers of dichlorobenzene would exist? So what he's asking for is that if you get rid of 2 of the hydrogens and you in its place replace it with a Cl, so how many isomers would you have? So you'll either have, that's
3.
well, you would have to draw all of them. Okay, let's do this. So either and he said assume that all the bonds remain in place. So one thing is that the 2 Cls are next to each other, right? So that's one. And in between the 2 Cls, the carbons are making a single bond. So that's one. Adjacent carbon atoms, that's one. The other option is maybe you got 2 Cls right next to each other, but between them, they've got a double bond. So that's number 2. Is that clear? These are the only 2 possibilities when the Cls are next to each other. Is that clear?
Yes, sir.
Yes, sir.
Yes.
I said then the Cls might be slightly far away from each other. So there could be 1 Cl over here and 1 Cl like 1 carbon atom away, right? There's going to be a carbon atom in the middle. So they're going to have a double bond between them and a single bond between them. So that's one possibility. So that's your third with a gap of 1 carbon atom. But they won't have any variation. It's like with a gap of 1 carbon atom, that's the only possibility, because wherever I put the Cls, like 2 Cls not being adjacent to each other, like if I put a Cl over here and then 1 carbon atom with a gap of 1 carbon atom, put a Cl over here, I still have the same arrangement. You've got a double bond and you've got a single bond in between. Right? Is that clear?
Yes, sir.
Yes, sir.
Yes.
So with a gap of 1 carbon atom, you pretty much get a single isomer. That's it. Then the next one is, what if I have a gap of 2 carbon atoms? So I've got a Cl on top and I've got a Cl right at the bottom. So in this case, I'm also going to get just 1. So that's my 4th one. So in this case, I'm also just going to have 1 isomer, because wherever I put the Cls, like right opposite to each other, it's going to be the same thing. Like if I put it over here, I still have on one side, I've got 2 single bonds and 1 double bond. On the other side, I've got 2 double bonds, 1 single bond. So it's going to be just a rotated version of the same thing. So I think it's going to be 4. You clear this one?
Yes, sir.
Yes, sir.
Yes.
But let me just double check this one. In cyclic structures, you don't have cistrons. Remember that, because you can't twist one side. There's no, You can't do that in a cyclic structure. Question number 20, that is B. And B is 40, that's fine.
Sir?
Yeah.
Sir, what do you mean that you can't twist it?
Not in a, like this is what cis trans is, right? In cis trans, what you had is that in the other molecule, like this one has cis trans, this is the cis version, right?
Yes, sir.
So there's going to be another molecule, a different version where the orientation of the bonds, the Cl would be pointing upwards and the H will be pointing downwards, right?
Yes, sir.
So one side is twisted, like it's connected the other way around. So you can't do this over here. Like over here, look at this fact that you've got a double bond, right?
Yes, sir.
So it's meeting the conditions that you've got a double bond. But in the double bond, one side, the two sides are different as well. You got an H, and on the other side, you got a carbon connected to it. You got an H over here, and you got a carbon connected over here, right? But I can't make the other version. I can't change the other side, because if I do that, I would have to like break the
You
ring.
have to cut it, yeah.
So that's a structural isomer then, because in a stereoisomer, you don't change the bonds.
Okay.
You just change the direction of the bonds. You don't change the bonds themselves. So which is why you don't have stereoisomers, at least cis trans in cyclic structures.
Okay.
And I think the reason why people might have gotten this question wrong was that they would have started thinking about cis trans, and you don't have cis trans in cyclic structures. Now this one has cis trans, but he's actually talking about chiral centers. So how many chiral centers do you have in this molecule?
Just one.
TK, which is I think 4 different groups. That's probably this one, right?
Yeah.
Because any carbon that's making double bonds, that's not going to be chiral. This carbon over here has 2 H's bonded to it. So that is also not chiral. So just one. PVC is difficult to dispose of. 2 possible methods are burying it in landfill sites and disposal by combustion. Which row of the table is correct? Rate of biodegradation, biodegradable. Is it biodegradable or not? PVC.
No, it's slow.
No, sir.
It gets slow. It's going to take 500 years for it to decompose. And if you burn them, what gases will be produced?
Is it C?
D.
So
It's good.
It's
It's going to produce HCl. Can you remember chlorine is very reactive. So when you're heating it, chlorine is, and plus there's light as well. So chlorine radicals will be formed, and chlorine radicals will react with any of the people speaking of what's free radical substitution. It's the same thing, right? You have chlorine, and just under UV light, it starts reacting. It starts stealing hydrogens from the organic molecule and starts forming HCl, right? So it's definitely going to be HCl, not Cl2. But is this point clear?
Yes, sir.
Sir, where can I find PVCs?
Hmm?
Sir, where can I find PVC?
Like in the notes or what?
Yes, sir, in the notes or like in general, like in the textbook or whatever, yani.
No, this is like all levels. Let me just show you. 1 second. Where's the?
Sir, was it in organic?
It's an organic, yes. And let me just go through this. Like where's alkenes? Just a second. This is free radical substitution, and now this is addition polymerization, right? PVC
Yes,
is
sir.
polyvinyl chloride. That's so this is addition polymerization, that you bunch of monomers of alkenes that join up and they form a polymer. And this is like 2-methyl propene getting polymerized. And you had some examples like PVC, that's polyvinyl chloride. That's used in PVC tiles, doors, windows, etc. So it's just like ethene, but they've got a Cl as well. And so that's your polymer of PVC. Is that clear?
Yes, sir.
So next part is 1 second.
Sir.
Yeah.
Just going back to question 21, sir.
Uh-huh.
Are you sure there's a chiral sensor? Because the one you highlighted, isn't it connected to two same gates of CSP?
That's same group. It's not chiral.
So are there no chiral sensor then?
So that means it's going to be 0.
Oh, okay.
Tiga, I didn't see that. They were exactly the same. So next one. Okay, you've got this thing which is what functional groups are present in this molecule? What is this? I mean, what's this thing? कौन सा functional group है? That's Humaid क्या है? What's this?
ester group, ester linkage.
That's an ester. ठीक है, that's an ester.
Oh, that's so.
So that's an ester. Serial bond O and O in the middle of the chain. Anyways, so वो कह रहे that's this ester in the reaction is bound with sulfuric acid. So when you heat an ester with dilute sulfuric acid, it breaks down. It turns back into the double bond O side turns back into a carboxylic acid. And the single bond O side turns back into an alcohol. So that is what happens. So when you heat it with sulfuric acid, it will break down. And just a second. So it's going to break down. And this side will break down. It will break in the middle. And it will eventually turn into a carboxylic acid with dilute sulfuric acid. And then it's treated with hydrogen in the presence of a nickel catalyst. Hydrogenation happens. So what happens to the alkene double bonds over here?
So it breaks.
Okay, so they would all go away and they will become saturated. So instead of having double bonds, all the double bonds would go away. Hydrogens are going to get added. And you will no longer have double bonds. It's going to become an alkane. So which one is the correct one? I think it's A. A, you know, is that the correct one, right?
Yes, sir.
Yes. Yeah.
Okay, so that's A. Then he says chloroethane can be used to make sodium propanoate. The intermediate Q is hydrolyzed with boiling aqueous NOH to give sodium propanoate. So I have a halogenoalkane, which is chloroethane. So I have my starting point is chloroethane, that's Cl. It's a halogenoalkane. And I want to make sodium propanoate. Prop means 3 carbon atoms. Propanoate means it's a salt of the carboxylic acid, which is so instead of OH, it's a salt. So there's instead of the H, it's Na+1, sodium propanoate. So I want to make this thing. So I'll open the chart. Okay, how do you go from a halogenoalkane to a carboxylic acid or its salt? So where's the revision chart?
Where is it from like by nucleophilic substitution?
It's going to be
nitrile?
Yeah, nitrile,
Then
yes.
like hydrolysis?
Yes. So if you have a halogenoalkane, you can substitute the halogen with a CN nucleophile. NaCN ethanolic and reflux. And then what you can do is that NaCN nitrile could be hydrolyzed to a carboxylic acid. But if you use alkaline conditions, you'll get a salt of the carboxylic acid, not the carbo. So it's basically this part that they're talking about. Halogenoalkane, you increase the carbon chain, and whenever the number of carbons increase, that is an indication that CN is getting attached to it. So that's the answer for this one. Can't get paper. So what is the reagent produced, would produce the intermediate Q from chloroethane? So that's NaCN or KCN. That's going to be D. The first thing is that you'll have a CN. So now you have got 3 carbon atoms. And once you have 3 carbon atoms, it could be hydrolyzed to a carboxylic acid. Or if it's alkaline hydrolysis, you'll get a salt of the carboxylic acid. TK, is this clear?
Yes, sir.
Yes, sir.
The next part is X, Y, and Z are 3 isomeric alcohols. 2 or more of these alcohols react with mild oxidizing agents. One of these alcohols, when dehydrated, will give a pair of cis-trans isomers with the molecular formula C5H10. So he's saying, so who's the one that's going to react with mild oxidizing agents? Which of the alcohol will not react with a mild oxidizing agent?
Here I think it is Z.
Remember, tertiary alcohols don't get oxidized. Primary and secondary, Joanna, this ones. Primary alcohols will turn into an aldehyde, and aldehyde will get further oxidized to a carboxylic acid. Secondary alcohols will turn into ketones, but tertiary alcohols have no oxidation whatsoever. So this one, I think, is like, if we draw this, it's a carbon with an OH, and it's got 2 CH3 branches. And it's got another CH2 CH3 branch on the right side. So that's a tertiary alcohol. That's not going to get oxidized. So X and Y, what is X? Is it primary, secondary? Which one is this?
Sir, primary hai.
TK, primary. What about this one?
Secondary, sir.
TK, this one is a secondary. So X and Y only. So which one will dehydrate to give? There's only one that gives cis and trans isomers. So which one? As a first thing, well, ek to draw on this one Z. So will this give cis trans when you dehydrate it? What happens when you dehydrate it? It's kya hoga? OH is gone.
Sir, double bond aayega aur water release ho jayega.
Ab double bond kahan pe aayega? What are the positions of the double bond? It's either going to be over here or over here or over here, right? So you've got 3 options. The double bond would be around this carbon atom. So if it's over here, will it be a cis trans? Like let's it's over here. So will that be cis trans? And there's going to be 1 H removed from here. It's not going to be cis trans because this carbon will have 2 H's,
No,
right?
it's 2 S, sir.
So it won't be cis trans. So what if this कोई यहाँ से हटा देते हैं? So that's gone. So what if the double bond is over here? That's the same thing. It's not going to be cis trans because again 2 H's, right? Finally, what if the double bond is on the other side? So again, it's not going to be a cis trans because you got 2 CH3s over here, which are the same groups. So in either case, whenever you put the double bond, you're not going to get cis trans. So this one is no cis trans whatsoever upon dehydration. What about the first one?
Sir, वो भी नहीं होगा, वो भी CH2 बन रहा है.
ठीक है, क्योंकि वहां पे भी ना that's 3, 4, 5 carbon atoms. And double bond would be over here. So you'll have 2 H's on the right side. I mean, the OH will be gone and the H is lost from the neighboring carbon atom. So it's not going to be cis trans. This one will be Y. If I draw Y is this thing. It's C, with another C, and 2 C's on this side, and there's an OH right in the middle. So, and these are all your H. So in this case, when the OH is lost, the H is lost from the neighboring and you'll get a double bond. And that will be cis trans because there's an H and there's a CH3 group on both. So two different groups. There's an H and there's the CH2, CH3 on this side. So it will form cis trans in this case. You get clear?
Yes, sir.
तो कौन सा ऑप्शन है फिर?
Sir, C हो जाएगा.
ठीक है, so it's going to be C. So next one is so it's going to be C. Next one. Okay, propanone reacts with an aqueous mixture of HCN and NaCN. So this is nucleophilic addition. This is the reaction of aldehyde and ketones with
Sir, D होगा.
with HCN. तो ये उसका mechanism है. ठीक है, CN-1 is going to attack the carbon positive polar carbonyl group and it will join with it, and oxygen -1 will then get attached to H+1. तो क्या है D?
Yes, sir, D बन रहा है.
ठीक है, so the carbonyl group is partial positive, partial negative, and CN-1, the lone pairs must be on the carbon. So D is the correct option. So nucleophilic addition, that's 26 is D. ठीक है. अब उसके बाद ये कि you've got P, Q, and R are carbonyl compounds. All of them are carbonyl. They look slightly different. They're slightly different. Felling solution can be used to help identify these compounds. Which compounds? So Felling, which substance will Felling react with? Like, do they react with that? ठीक है, Felling is a test for aldehydes. Aldehydes का test है, ठीक है. Ketones don't get oxidized. Aldehydes, they do get oxidized to carboxylic acid. They can be oxidized with Felling, and that's brick red precipitate. तो यहाँ पे ना, which ones are aldehyde? What's the first one? Is this an aldehyde?
Sir, उसकी एक side बन रही है, दूसरी नहीं बन रही.
So ठीक है, aldehyde है फिर. That's. So what about the next one? It's an aldehyde as well. And the third one that's a ketone. Both of them. Okay, so which compounds form a red precipitate? P and Q only, right?
Yes, sir.
Both of them are going to get oxidized. Asafir, next one. Which reaction would not give ethanoic acid? Not. Ethane nitrile, we just did that. Ethane nitrile is this thing. It's 2 carbon atoms, nitrile. So we just said if you heat it with NaOH or you hydrolyze it, it will turn into a carboxylic acid.
चल के उसका salt नहीं बनेगा.
हाँ, लेकिन since the conditions are alkaline, you'll get those. Option A is the correct one. You're not going to get ethanoic acid. You're going to get a salt. Second, you're going to get ethanoic acid. If you heat a nitrile with sulfuric acid, you are going to get carboxylic acid. As I heat it under reflux with potassium with sodium dichromate 6, aldehyde will turn into carboxylic acid. Ethanol will also turn into carboxylic acid. So 29, which formula represents an ester that will form propanoic acid on hydrolysis with sulfuric acid? So all the esters will break down. So who's going to form propanoic acid?
A.
Okay, so 3 carbon atoms. And the double bond O side turns into a carboxylic acid. So that is propanoic acid. That's 3 carbon. So A is the answer, this one. Okay, clear?
Yes.
So next part is you've got a solid X is used in printing inks. Has the molecular formula C6H10O4. It may be made by reacting ethane 1,2-diol with ethanoic acid in the presence of an acid catalyst. So ethanoic acid. So this is an alcohol, and ethanoic acid will form an ester. So this is ethanoic acid, CH3C double bond O, OH. So an alcohol and an ethanoic acid, they will react together and they would form an ester. But it's got another alcohol as well. So it will form another ester with ethanoic acid. And there are 3 H's. So it will form another ester on the other side as well. You get the formula of the compound, the product is 6 carbons. So you'll get 6 carbons this way, 2 carbons, 2 carbons, 2 carbons. So that's a total of, that's going to be a total of 6 carbon atoms. So the OH is lost. H is lost, OH is lost, H is lost, and they'll connect in the middle to B.
Yes, sir.
Yes, sir.
ठीक है, double bond O and then O. ठीक है, double bond O and O. So it's going to be B. That's the last section. Okay, a sample of boron contains aluminum as the only impurity. A mass spectrum of the mixture shows 3 lines corresponding to the 3 ions X plus 1, Y plus 1, Z plus 1. So this one is aluminium, right? Aluminium is 27. And these two are definitely isotopes of boron. Boron is around 10 or 11, right, in the periodic table. So that both of them are boron isotopes. So which statement are correct? There are more electrons in Z plus 1 than in X plus 1. Which is kind of true that Z plus 1 is a much bigger atom, right? Is that clear?
सर आपने कैसे डिसाइड किया कि ये बोरॉन है और एल्यूमिनियम है?
Mass है ना, aluminium periodic table में देखो ना, that's
सर Y अगर 11 है तो वो Na नहीं हो सकता.
it's a mixture of boron contains aluminum as the only impurity. So it's either boron or it's aluminium.
Okay.
So the first one is true, right? Because Z is aluminium, so it definitely has more electrons than boron. The AR of boron in the sample is 10.83. So how do you find the AR, relative atomic mass? You use the average, you find the average, which is the mass of the isotope, which is 10, multiplied by its percentage, which is 15.52, plus the mass of the other isotope, which is 11, multiplied by its percentage, which is 74.48. So क्या what do we get for this?
$9.7448.
No, you can't get 9.7448. अच्छा नहीं, sorry, हाँ एक मसला हो गया. पहले तो, do you understand? You can't get 9 point because one of them has a mass of 10, the other one has a mass of 11. If you take the average, it will come, the mass will come somewhere between the two. So what did I do wrong over here? What's my mistake?
Is it the divide by 2, sir?
ये टोटल 100 नहीं हो रहा है इसका जो
हाँ,
परसेंटेज
exactly.
है बने से.
क्योंकि एल्युमिनियम को तो 20 में निकालो ना, it's, you're not going to include aluminum in this. So 100, so it's not, the percentage is not out of 100, it's actually out of, what's the total? 74.48 plus 15.52. What do you get? I think that's 90. Okay, that's the error. Okay, aluminium has nothing to do with the average mass of the isotope. So they calculated the percentage including aluminium. So we have to remove aluminium out of that. Okay, is this part clear?
Yes, sir.
So what do you get now? I think it's going to be 10.83. Can you just check whether it's 10.83 or not?
Yes, it is 10.83.
So then the third one, there are more protons in Y+1 than in X+1. Is that true?
नहीं सर गलत है.
Because they are both borons, right? So any atom of boron will have the same number of protons. The only difference in isotopes is the number of neutrons. They always have the same number of protons. So that's wrong. So which elements can form pi bonds in their compounds?
सर सारे बनेंगे.
All of them, carbon dioxide, you got double bonds. Anything that's got double bonds, that's pi bonds. Oxygen can form double bonds with a lot of things. Like in carbon dioxide, oxygen is making double bonds. Nitrogen can form double bonds like in NO2. So all of them are forming double bonds. So all three are correct. For which enthalpy changes is the value of delta H always negative?
Combustion sir.
It's always negative. These two are no longer in AS. Forget those. Next part is sulfuric acid is being manufactured. Which changes will move the position of the equilibrium to the right?
So increasing pressure, low gas smooth side हो जाएगा.
Is this Usikava? It's an exothermic reaction.
So उससे तो backward चला जाएगा ना अगर forward exothermic है.
Increasing the temperature will favor the endothermic reaction, which is not going to happen. Does catalyst affect the equilibrium position?
No sir.
वो affect नहीं करता. अच्छा, फिर है कि 35. What is added to aluminum chloride to make a 0.1 mole per dm cube solution? Which observations are correct? अच्छा, what would happen if aluminum chloride is added to water?
So aluminum hydroxide बन जाएगा plus HCl.
I mean, that's the overall equation, the simplified version. That's this one. That when you react it with water, it will form aluminum hydroxide and it will form HCl. But that's the simplified version. Okay, the next again. So, the more detailed one. What is the more detailed one? What happens when aluminum chloride is added to water?
So
A complex ion is formed.
सर वो जो आखिरी वाली है सर एक तो वो और हाइड्रोलिसिस होता है.
पहला होता है कि this happens, that aluminum chloride first dissolves. Now this is the detailed version. It forms aluminum 3+ aqueous and it forms a 3Cl-1 aqueous. And after that, what happens is that the aluminum forms a complex with water. It is surrounded by 6 water molecules, 3+1, and it then ionizes and forms AlOH3, which is in the first one, right? It basically does the same thing. So that's kind of the overall reaction. This is the more detailed reaction. And there's 3 H2Os and plus 3H+1. And this is, so the detailed version is this one. Okay, where's the hydrolysis? This part, I think. Yep. The detailed version is this one. Then what happens is that why does aluminum have a strong hydrolysis? Because when aluminum is finally dissolves in water, what happens is that it gets surrounded by water molecules. And because it's got a very strong positive charge, so the attraction is very strong. So it very strongly attracts water molecules. But at the same time, it very strongly repels the positive H atoms in the water molecule. And the water molecules, they start breaking down, they start ionizing, they start hydrolyzing. So aluminum in the water attracts the OH ions, but repels the H positive ions. So it keeps the OH ions, but repels the H positive ion, which is why it ionizes. And that is what happens. So coming back to the question. So you're going to get aluminum hydroxide and you're going to get a lot of HCl in the solution. The solution is acidic. And the solution contains Yeah, in Al and with water molecules. And is it exo or is it endo? Kya hoga? This one. Exo or endo? Is this a vigorous reaction, or is it a strong hydrolysis or weak hydrolysis?
So strong hydrolysis hota hai.
It's a very vigorous reaction and it produces a lot of energy. So it's an exothermic reaction, not an endothermic reaction. A lot of heat is produced, which is why you see fumes of HCl gas. Most of these reactions, hydrolysis reactions, are very exothermic and they're very vigorous. As a next one, catalytic converter. Which reaction occurs in catalytic converter? The 1, 2, 3. Which ones are happening in the catalytic converter?
So 1 or 2.
Hydrocarbons are turning into carbon dioxide and water. That's true. Nitrogen monoxide. That's also true. They're converted to less harmful products. The last one is not true, because you're still getting harmful products. So catalytic converter's job is to produce less harmful products. So which compounds would produce a carboxylic acid and a ketone when treated with hot concentrated KMnO4? What happens in strong oxidation? Kahan pe wo?
Double bond se break ho jayega.
As a double bond toot jata hai, double bond breaks, and you got 3 options. If you got 2 carbon chains, it will turn into a ketone. If the double bond has 1 carbon chain, it will turn into a carboxylic acid. If it's got 2 H's, it will turn into carbon dioxide and H2O. So yahan pe na, the double bond will break. So
And pehla ketone or carboxylic acid hoga.
Pehla sahi hai na, ketone and carboxylic acid, right? So the double bond in the middle, that's going to break. And if you look at the 2 carbons, this one will be a ketone. It's got 2 carbon chains. And this has 1 carbon chain, so it will turn into a carboxylic acid. So what about the next one?
So ketone and carboxylic acid.
Again, ketone and the double bond will break completely. And in the middle, it's going to be this one will be a carboxylic acid. It has 1 carbon chain attached to it. And this one will be a ketone. It's got just 1 carbon chain. So carboxylic acid, this one has 2 carbon chains. So that's ketone. So last one.
Sir, ketone carboxylic acid.
So all 3 are correct. The last one also, the double bond breaks. And this one has 1 carbon chain, so that's carboxylic acid. This one has 2 carbon chains, so that's a ketone. So all of them are correct. Clear?
Yes, sir.
Achha, phir ye ki 38 bromoethane reacts with NaOH, and it reacts in different ways depending on the solvent that is used. So bromoethane is this thing. What are the 2 ways in which NaOH reacts with it?
Sir, ek to uska SN hydrolysis hoga, dusra elimination.
Dusra kya hoga? Elimination. So this is the reaction that if you have a halogenoalkane, so if you use NaOH KOH ethanolic, it's going to turn into an alkene. But if you use NaOH aqueous, then it will turn into an alcohol. So you've got 2 options. One is that either this will be replaced by OH. For that, you would need water. So that means 3 is correct, right? If you use NaOH aqueous, water as a solvent, it will turn into an alcohol. Clear here? But if you use ethanolic NaOH, then you won't get water. What you'll get is a double bond instead. You'll have an elimination reaction and it will turn into an ethene. First one is wrong. Diol nahi banega. You're not going to get a diol because you just have one Br and it's going to be replaced by 1 OH. So the first option is wrong. So yeah.
Yes, sir.
You can always remember KNOH when it reacts with halogenoalkane, it can either do a substitution. For that, it has to be aqueous, SN1, SN2 nucleophilic substitution, or it will do an elimination if it's ethanolic NOH. I said this one, which statement about these structural isomers are correct? So these are structural isomers of C3H6O3. 1 mole of each reacts with 2 moles of sodium. What does sodium react with?
सर एसिड के साथ वाटर और उसके साथ अल्कोहल.
ठीक है, so it reacts with carboxylic acids and it reacts with alcohols. And one sodium is going to replace one H. ठीक है, and it's going to take यहाँ पे RCO minus 1 Na+1. That is what's going to be formed. So the first one, it's got 2 alcohols. So how many sodiums do you need? You need 2 sodiums, right? Second one, you've got again 2 alcohols, an alcohol, a primary alcohol, and a secondary alcohol. Again, you need 2 sodiums, right? As a third one, you've got an alcohol and you've got a carboxylic acid. Again, you need 2 sodiums. The last one, you've got an alcohol and you've got a carboxylic acid. Again, you need 2 sodiums. So that's true. 2 moles of sodium are needed. Okay, clear?
Yes, sir.
So what about the next one? It's a tertiary alcohol group. Which one has a tertiary alcohol group? Tertiary alcohol group. I don't think anyone has a tertiary alcohol group. Like if I were to draw the last option, CHOH, the middle one has, but any carbon with 1H, it's not going to be tertiary. It has to have 3 carbon chains. One side you've got a carboxylic acid, the other side you've got a CH3. So again, that's a secondary alcohol, not a tertiary alcohol. Is there any? There's no tertiary alcohol group, I think. Is that clear?
No, sir.
They all contain
sir.
I said they all contain a primary alcohol group. Okay, this is primary. This alcohol is also primary. Any alcohol that's at the end, that's usually primary. So this one is also primary. The last one does not have a primary alcohol. It's in the middle of the chains. That's a secondary. So this option is also incorrect. Say last one. You've got you've got a molecule. Onions are peeled, but then this reaction happens. Which test would give a positive reaction with the organic product? This is the. Are all these the organic? This is the organic product. Okay, there's an arrow over here. So that's the organic product, and it's an aldehyde. So toluenes, will it react with toluenes?
Yes.
It will get oxidized. It will get oxidized by KMNO4 as well. Okay, there are four things that can actually oxidize an aldehyde: toluenes, phenylene, K2Cr27, or KMNO4, all of them. So what about the last one, alkaline acrocyidine? Will it react with it? Iodoform test. When you have a positive iodoform test, when you have a methyl which is next to a C double bond O.
There's no methyl, sir. There's a ethyl.
Over here, you have an aldehyde, but the methyl is not next to a acetyl bond. You need a methyl next to a acetyl bond. So this is the last one is not going to happen. Okay, so 40 ka kya hai? That's 1 and 2 only. Okay, that's going to be B. Clear?
Yes, sir.
ठीक है, फिर अब कल ही होगी class. We'll have it day after tomorrow. What's Monday, right? We'll have it on Wednesday. Yes.
आपने AS and A2 की ऑल्टरनेटिव क्लासेस रखी हुई हैं, अब कल A2 की होगी
हाँ कल 2 की होगी।
और इसी टाइम पर 8:45।
हाँ
ओके सर,
चलो ठीक, ओके,
अल्लाह हाफिज।
हाफिज।
Yes, sir.